Compare fractions with different numerators and denominators. Let's take a look. 7 questions. Hopefully that usually means they're pretty quick. We are just comparing whether these are greater than, which one's greater, which one's less, or are they equal. 2/3 and 9/12. There are lots of ways that students can do this. At this point, we've probably got a good solid 10 or 12 videos behind me on how we can make this work. You can compare each of them to 1, although in this case, they're both less than 1, so that doesn't help. Or you can try to find a common denominator and count them up that way. That definitely works. So in fact, I think that's what we're going to do here. 2/3 is blank over 12, yeah? Well, I have to multiply 3 times 4 to get 12. Again, it means that I'm taking the total number of pieces and quadrupling them. So if I have 2 out of 3 pieces, and all of those pieces get quadrupled, they all get cut into 4, then the 2 also gets quadrupled. Give me 8/12, which is indeed less than 9/12. Not by a lot, but definitely less. Two-sixths is in fact the same as 1/3. I'll give you a sec to figure out why on your own using whatever method you want. 2/3 and 1/5. In this case, so we kind of have 2 ways of telling whether a fraction is bigger or smaller just by looking at it. If we know like 1/3 is less than 4/3, yeah? If they have the same denominator, that means that each piece is the same size, then the one that has more pieces wins, right? 4/3 beats 1/3 because there's 4 of them and they're all the same size. It also works to compare denominators, right? 3/5 is less than 3/2. Because if you have 3 of one thing and 3 of another thing, halves are bigger than fifths, right? A half is when something is cut into 2. Fifths is when something is cut into 5. So if you have the same number of things, the same numerator, the one with the smaller denominator is actually going to be bigger because smaller denominator means that each whole was cut into fewer pieces. In this case, though, 2/3 and 1/5, both of these are true. The numerator is bigger and the denominator is smaller, so definitely 2/3 is greater than 1/5. Four-fifths and 6/8. Now, this is a tough one. This is a really tough one. Finding a common denominator here would be pretty gross. It wouldn't be very easy or simple to do. So instead, I'm going to go ahead and use our rectangle diagrams. Okay, so I'm going to make a rectangle. I'm going to make another rectangle. And once again, I'm going to try to make them the same size. That one, it didn't even register as a rectangle. Good job, me. There we go. Those are roughly the same size. They're not quite exactly, but that's okay. I'm going to split one of them into 5, which is going to be a little bit tough, but we'll see what I can do. 1, 2, 3, 4, 5. Those are more or less equal. And then this one goes into 8. Now, if I'm cutting something into eighths, I cut it in half first. Then I sort of visually cut each of those into half so that I get fourths. And then I cut each of those in half to get eighths. I'm going to try to be kind of precise here. And we want to know 1, 2, 3, 4/5, or 1, 2, 3, 4, 5, 6/8. Now that's awfully close, friends. That is very close. But if my diagrams are reasonably accurate, and I think they are, it looks to me like 6/8 is just slightly less than 4/5. I would definitely call this a challenging problem at a 4th grade level at this particular stage in the game, which of course makes it a great problem to check for understanding with. Because it's not obvious, it's not easy, but it is doable. 1/4 is, again, definitely strictly less than 2/3. I don't even really need to think about it that hard because, again, the numerator is smaller, which means there's fewer of them, right? And the denominator is bigger, which means that each one was cut into more pieces. Each piece is smaller. A 4th is smaller than a 1/3, assuming two objects are the same size. So 1/4 is smaller than 1/3, let alone 2/3. Now, 1/4 and 3/5, that's a little bit tougher. That's a little bit tougher. I'm pretty sure it's going to be 3/5 is the correct one. And the way I can do that is by kind of comparing it to halves. But let's go ahead and make a diagram anyway, just in case. I want to make sure that all of these different techniques are being used sort of in variety. So this time we're going to use circles. There, we've got 2 circles. One of them is going to be cut into 4ths, and one of them is going to be cut into 5ths, which isn't super easy, but I think I can manage it. There we go, close enough. We've got 1 in 4ths and we've got 1 in 5ths. In this one, we've got 1/4. In this one, we've got 1, 2, 3/5. And again, even with my pretty shoddy drawing here, should be pretty clear that 3/5 is larger, therefore 1/4 is smaller. Last question, 4/2 and 5/3. This is a really good one to end on because they're both greater than 1. But 4/2, you might recognize, is 2, right? If I have one, 2 circles, boy, I am just failing so hard at making circles today. If I've got 2 circles and they're each cut into 2, right? They're each cut in half. Then 4 halves, 1, 2, 3, 4, would be exactly 2. And again, that shouldn't be terribly surprising because 4 divided by 2 is 2. Remember, fractions are division. Division is fraction. It's the same thing, and it follows the same rules. On the other hand, if I split each one up into 3, which looks kind of like this, like a peace sign, and I label 1, 2, 3, 4, 5 of them, well, that's not quite 2. So now instead of comparing things to 1, I was comparing them to 2, and 5/3 comes up just a little bit short. Four halves is greater than 5/3. And that is compare fractions with different numerators and denominators. I'm proud of us. Let's move on.